Math 107, Lesson 12, Demo portion. Sometimes a function may need more than one formula to accurately model a real-life situation. For example, taxi fares, the US tax code, late fee charges for credit cards, etc. They all require a function to use more than one formula to model them. In these situations, the function is defined on different pieces of the domain, so we call it a piecewise function. So here, this is the graph we just worked with in the preview exercises. It represents a piecewise function because it has three distinct pieces, each of which needs a different formula to describe it. So I didn't give you any context in the preview exercises, but this graph actually shows the amount of water in thousands of gallons in a swimming pool after T hours have elapsed. So I added some labels here for the X and Y axes. How has the amount of water in the pool changed over the domain? So it looks like in this first 20 hours, the pool was being filled. And then from hour 20 to hour 30, the pool stayed at a constant level of 8,000 gallons. And then from hour 30 to hour 50, the pool was draining from 8,000 gallons down to 0 gallons. Over what interval is the water level in the pool decreasing? Write your answer as an inequality. So it's decreasing from time 30 to time 50. So we'll say time bigger than 30, but less than 50. And we should not be including the endpoints for decreasing or increasing. On what interval is the water level increasing? From time 0 to time 20. So we sandwich time from 0 to 20 here. Over what interval is the water level in the pool constant? 20 to 30. T is between 20 and 30. These three intervals define the different pieces of the domain for our function. We can represent this pool problem by writing the number of gallons in thousands G as a function of the number of hours T using a piecewise function. So this is our standard notation for a piecewise function. You have G of T or F of T or whatever the name of the function is equals. Then you put one big curly bracket, and then you list all of the different formulas that might describe your function. So we found these formulas in the preview exercises, 0.3t plus 2, 8, and negative 0.4t plus 20. And then you add if next to each formula, and you give the interval on t for which that formula applies. So 0.3t plus 2, that is the formula that applies when the pool was filling with water from t equals 0 to t equals 20. 8, that's the formula that applies when the pool was at a constant 8,000 gallons from t equals 20 to t equals 30. And that negative 0.4t plus 20, that was when the pool was draining. That happened between t equals 20 and, 30 to 50. That happened from 30 to 50, like that. In general, a piecewise function looks like this. F of x equals formula 1, formula 2, formula 3. You might have a formula 4 or a formula 5. You might only have 2. And then you put if and give the domain where you use each particular formula. So here's an example of a piecewise function. Cell phone plan with Verizon Wireless. They charge $79 per month for 700 minutes, and any minutes over 700 is charged at 45 cents per minute. So you have two different formulas. One formula if you talk for less than 700 minutes, or up to 700 minutes, your bill is $79. If you go over 700 minutes, there's another formula you have to use to calculate your cost. All right, so let's just figure out how much does it cost if you talk for 535 minutes. Okay, so word C is going to represent cost, and M, the number in parentheses, is minutes used. So 535 minutes means $79. We're under the 700 threshold, so $79. I'm not going to write down the interpretation. I just said it out loud. But if you talk for 850 minutes, that is over your 700, right? So you're going to have to pay for the overages. So it's going to be 79. You have to pay the 79 no matter what, but then you have to pay your overages, right? So how much did we go over by? So we spoke for 850 minutes. How many extra minutes do you have to pay for? And the answer is 150, right? You have to subtract the number of minutes you talked, subtract the 700 you already paid for, and you have to pay for that 150 extra. And those are 45 cents a minute. So you do 0.45 times 150, and that comes out to be, grab my calculator, 0.45 times 150 is 67.50 plus 79. That's 146.50. Okay, so if you talk for 850 minutes, it costs $146.50. All right, so I want to use a piecewise function to represent the monthly cost for m minutes. Okay, so I have two different formulas. The first one's easy, right? So the first one is, I'm going to make this a little bit bigger here, 79 if m is less than or equal to 700. If you're under 700, your cost is 79. Easy formula. Okay, but if m is greater than 700, we have to do this other formula like we did for the 850 minutes. So it's going to be 79 plus 45 cents for every minute you go over. So you have to calculate how many minutes you talked, which is m, and subtract the 700 minutes you already paid for, just like we did up here, right? We did 850 minus 700 there. And that formula we use if m is bigger than 700. So that's my piecewise formula for my cell phone plan. All right, finally, we want to be able to sketch the graph of a piecewise function. So I have f of x equals x squared when x is between -3 and 1, and 1 minus x if x is between 1 and 5. So I personally like to just graph both of these and then erase the parts that I don't need. So I'm graphing two functions, y equals x squared, right, and y equals 1 minus x. Make an XY chart for both of them. And I think I'm going to do one of them in green. Okay, so for x squared, my domain looks like -3 to, I'm just going to go -5 to 5. So -5, -4, -3, -2, -1, 0, 2, 3, 4, 5. And figure out the y's, and then I'm going to plot them all. So I have 25, 16, 9, 4, 1, 0, 1, 4, 9, 16, 25. So I'm going to start with 0, 0 and work my way out. So I've got 0, 0, 1, 1, 2, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm not going to plot 4, 16 because it's going to go off my graph. So now I'm just going to do the other side. -1, 1, -2, 4, and -3, 9. Connect those with a nice smooth curve. So that's y equals x squared. Now I'm going to graph y equals 1 minus x. And maybe I'll go -5 to 5 again. And calculate the y. So y is always 1 minus the x. So 1 minus -5 is 6. 1 minus -4 is 5. 1 minus -3 is 4. 3, 2, 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 2 is -1, -2, -3, -4. All right, so I plot these points and I should get a line. -5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. -4, 5, -3, 4, -2, 3, -1, 2, 0, 1, 1, 0, and I get the idea here. Plotting points along this line and connect them. All right, so I've graphed them both. Now I want to just erase the parts that I don't need. So for y = x squared, I'm only supposed to draw that for x's between -3 and 1. So going back to my green graph, I only want that graph from x = -3, which is here, to 1, which is here. Anything outside of those brackets, everything outside of these fences, I want to erase. Okay, I'm only supposed to keep that graph between -3 and 1. I'm going to erase what's out here, erase what's over here, and -3 I'm supposed to include, so that's going to be an open dot. And at 1, I'm not supposed to include that, so I'm going to make that an open circle there. All right, and then I'm just going to erase my fences too. Those aren't part of the graph. They were just to help me decide what to erase. Okay. All right, so for my pink graph, I only want to graph x's from x = 1 to x = 5. So erase everything to the left of 1, which is right here. I'm supposed to include the 1, so I can put a big open circle there, a big closed circle on that 1, and then go till 5. So 2, 3, 4, 5, that's the last one I'm supposed to include. Erase everything after that. And then I want to erase everything before 1. Get my tiny eraser here. And erase everything before that 1. And I might have to go back and fix some things. All right, so my green graph, just kind of fix that. There we go. There's my graph. So I included my green graph, y = x squared, between -3 and 1, not including the -3, but not the 1. And then the pink graph, the line from x = 1 to 5, including both the 1 and the 5.